Welcome to the Cannabis Detox Programming Podcast with your host, the one, the only, Cannabis Detox. Okay, all right. So this is just going to be me bullshitting about programming for some indeterminate amount of time. I'm just going to be rambling on and on about whatever the fuck I want to ramble on and on about. You can listen. You can just fill your head with some wonderful, beautiful programming concepts while you do whatever the fuck you're doing. All right, I want to talk about recursion. Recursion. Oh yeah, baby. The beauty of recursion is lost on so many. People hear the word. They even understand the concept, but they don't get why it's a big fucking deal. Why does everybody always talk about this? Whenever I look up tutorials on how to do something, whenever I look at Stack Overflow, whenever I'm doing anything, people aren't using recursion. When I read books on how to become this awesome programmer, they never talk about recursion. So what the fuck? Why do these people always mention this shit? Why is it important? Okay. Recursion, first of all, is what the fuck is recursion? Right? Well, it's a way of writing instructions. Programming is really just we're all just writing instructions. Recursion does not apply to programming. It's a mathematical concept, and you can apply it to any set of instructions. And all it is let's say you're building some Legos, and maybe you're building a castle. And in the instructions for the castle, there's windows on each castle, and there's like a certain way that you build out each window. And every window, and maybe there's 20 windows that are built exactly like this, right? Maybe there's different types of windows, but this particular kind of window occurs 20 times throughout the set. And so they have the instructions there for how to build the window. And then when you have to build another window, it'll tell you to go back to these instructions, and it'll just tell you to repeat the steps that you did before. Well, that's basically what recursion is. It's about going back to a previous step and repeating what you're doing. A more accurate metaphor for recursion is really you have a set of instructions and maybe a subset of instructions, let's say 1 through 10, and somewhere along the lines, maybe on step 6, it'll tell you to start over at step 1. Recursion is basically you're going through instructions and you're starting over at step 1. In terms of programming, what does that mean if we're going to try to take that concept and use it to tell the computer what to do through this arbitrary programming language? What that means is I'm going to have a function, and that function represents a set of instructions, and I'm going to start over at step 1, and what that's going to mean is I'm going to start over at the beginning of the function, and the way that I start over at the beginning of the function is by calling the function by its own name from within itself. And I know that sounds a little hard to understand, but all that's really happening is you could have a function that's counting things up, and maybe you count this section, and then you just call the function from within itself to start over again. Kind of hard to explain non-visually, but you could have people always like to do the factorial example or the Tower of Hanoi for recursion, but the reality is that's not a real use case. More than likely you're going to use recursion anytime that you would use a loop. So if I had a bunch of enemies and I wanted to see If any of the enemies have less than 10% health, I would basically start with a list of enemies, and instead of looping through that list of enemies, I would just check the first. I would have the list of enemies, and I would just check the one enemy at a time. I would just check the first enemy, and then I would call the function to start over. But this time, instead of checking the whole list, it would check the whole list minus the enemy that was just checked. So it would check the rest of the list. And then that function would check the rest of the list minus, and it would, instead of checking the rest of the list, it would just check one at a time, right? And then, didn't mean to be this fucking messy about it. So yeah, so let's say you have a list of 3 enemies, okay? It checks the first enemy to see if it's below 10% health, okay? It's not. So now it's going to check the rest of the list. And the way it checks the rest of the list is it calls itself with the rest of the list. Well, now it's got 2 enemies left, right? Because one of them's already been checked. And the function just checks one of those 2 enemies and then calls itself with the remainder of the list, which would only be 1 element left. And if this is confusing, that's okay. Because recursion isn't really about the concept. The concept is why it's so powerful, but the concept is easy to understand. What's not easy to understand is how to do this automatically without thinking, is how to make it not confusing, to make it comfortable. And all that stuff is just practice. You just have to drill it over and over again. You know, recursion is only useful if you do it a million times. Recursion is not a useful tool if it's something you're only, you take it off the shelf, once every few months. This is just for these kinds of problems. No. Recursion is only useful if you're using it all the fucking time for all of your programming. Because by using it all the time, you're going to train your brain to think a certain way and to identify different patterns. And different concepts in programming, like callbacks, are going to be easy for you to understand if you program everything recursively. So now that I've done an incredibly shitty job of going over what recursion is, right? Really a function that calls itself, a set of instructions that starts at step 1. Now that you're thoroughly confused by that, let's talk about why recursion is even important. Why do we even talk about it? Because that's probably why you give a shit about why you're even listening to this. You probably already know what a recursion is. You can probably just Google a tutorial, but then you're like, well, now what? Well, the reason it's so goddamn important is because it is the grandfather of a lot of other concepts that have come later. In terms of like understanding, and it also helps you understand a lot of other shit. Like I said, callbacks. A lot of people struggle with callbacks. They really do. When I was programming in C#, a lot of people, it seemed to be the opposite. It seemed like everybody else understood callbacks and used callbacks all the time and was very familiar with them and used them like they were nothing when I was programming C#. It seemed like all the other programmers understood callbacks and they were just black magic to me. Now that I'm programming in JavaScript, it's the opposite. It seems like no one everybody's confused by callbacks. Even if they understand what they are, they still seem uncomfortable with them and they'll reach for something else instead. But really it's not. Callbacks are something that you need to be good with. You can't go through your programming lifespan without taking callbacks on as one of your tools in your own code that you write. It's not even about using the other tools, other people's libraries and stuff, and being familiar with them in terms of callbacks. It's about you need to be designing your own systems with callbacks. And what recursion will do for that is it'll force you to write functions that take other functions as arguments. And it will force you to do that, because you can't, with recursion, you can't just stick everything in one function. You can't just have these giant fucking functions that try to do everything and try to be completely self-contained. You're pretty much forced to break up your program into multiple small functions that all do little things. You're forced to break up the logic of your function, of what you thought was going to be one function, what you intend to call via your as one. You're only going to call the one function, but you're going to be forced to break it up into 5, 6 little functions to make that one function work. And it's counterintuitive. It goes against your better instinct. Your instinct when you're coding is to try to self-contain everything, is to try to encapsulate everything. That is your gut instinct. In fact, people will encourage you to do that. Will encourage you to encapsulate, to try to force everything into a single function. But as you get older, and if you talk to any more experienced programmer, they will tell you that a lot of little functions, a lot of small functions is the way to go. That is the key to eternal peace. Now, so that's why, recursion, beyond what it does for you in your code, it'll force you to code in a certain way. It'll force you to become familiar and confident with other techniques, besides recursion. Now, beyond that, when you look at things like map, filter, reduce, I get, these JavaScript kids are so fucking ignorant. They have no sense of where they've come from, of programming history, despite the fact that programming history is a joke. It's been around for a fucking lifetime, less than a lifetime. All these things are brand new, so it doesn't take that much fucking information to get a general grasp of what has happened in programming so far. And things like map, filter, and reduce, people will tell me are iterative, that they're based on iteration, they're based on loop constructs, and they're not recursive at all, which is just a fucking joke. They literally come from Lisp. Lisp is this language that was created in like 1959. It was created at the same time C was created. C was created about the same time, 1959, around that era. And at the time, there was no recursion. There was no way for a function to call itself. Everything was iterative. It was a brand new thing to actually be able to use recursion. And during that time, things like map and filter and reduce were created because they are natural shortcuts when you're working with recursion. The reason they're a more natural shortcut for recursion and not a loop, even though you can use them instead of loops, just like you can use them instead of writing out the whole recursive function. The reason they are a natural step is because, like I said, in recursion, you're forced to pass functions and take functions as arguments. You're forced to break your functions into multiple functions, and that's exactly what you do when you use map and filter and reduce. It takes in a function as an argument that you're going to use that you're going to apply to the list, and it's from recursion. It's from the language that we got recursion from. Like, it's not even up for fucking debate. And things like reduce, I mean, good luck trying to fucking understand reduce from an iterative perspective. I mean, that's a fucking joke. Reduce is an accumulator function. That's what it is, and it's been abstracted into an easier to use shortcut. Where because in an accumulator function, you have a parameter that isn't set by the user on first call. It's got some sort of default value, and its only job is to keep track of something while the function is running multiple times. So, like, when you're counting up a bunch of shit. But anyway, so okay, so you know that recursion can teach you something about callbacks, whatever the fuck those are. That has some sort of historical significance, at least according to some random dude. But why? That's cool. Okay, it can teach me some stuff and have some historical significance, but how is it going to make my code better? How is it going to make it easier for me to tell the computer what to do? Well, it's going to make it easier for you to tell the computer what to do because it's going to teach you how to program in a more mechanical way. What I mean by that is, like, let's say you're trying to do something. I don't know, what does try to do something mean? I don't know. We're making a video game. We're trying to draw we got a bunch of fucking duck enemies, and we just want to draw the duck enemies to the screen. Well, if we go about this recursively, we have to start with some sort of list. Okay, the list of enemies. Okay, and then we have to just start with the first. We don't think about all the enemies. We're just thinking about, when we do recursion, we only think about one thing in the list. So we take the list, we take the first thing in the list. So we're just talking about one duck enemy now. Right now I'm not worried about how am I going to draw all these enemies and I want them in all these different positions. No, I'm just thinking about one. Where am I going to draw this first enemy? And I'm not thinking and then coding. I can code and think at the same time. I can write out, okay, if the list is empty, I want to be done. Okay, otherwise let's take this first enemy. And I can be writing it out as I think. And I go, okay, I want to draw this enemy to the screen. Where do I want to be drawn to the screen? Well, the first one, I'll probably just want it, right on the top right corner. Okay, and maybe all the rest of them will be vertically down. But so I'll take the Y value of whatever the top of the canvas is, 0, I imagine, since everything's fucking upside down on the coordinate system. And then I'll take the X, which would probably be the maximum width of the canvas. And and that'll be my position for the first enemy. And then I'll think about the second enemy. Right now I've successfully solved the first enemy. Now where am I going to put the second duck enemy? Well, I want it where the first duck enemy is, but plus a little lower, right? Which is just adding a little bit of Y, a little bit of value onto the Y. And so all you would do is you would just rewrite that little line that you just wrote, but you would add, a certain amount times however enemies have been done so far, right? And you do it all recursively, and it's just, I don't know if you can tell, but it's just mechanical. You just go through the steps. Step 1, step 2, step 3. You start with a list of enemies, then you start with the first enemy, then you think about the second enemy, and eventually you've solved for all your cases. If you just do this for it doesn't matter what the problem is. You just try to break everything down into sets of things, and then you think of one thing at a time, one instance at a time, one case at a time. Okay, well, what if I have so many enemies that it goes past the bottom of the screen? Okay, maybe I want to create another row, right? So you just think of it at one case at a time, and it just makes it more automatic. I don't get stuck when I program recursively. I don't feel like, oh fuck, what do I do now? Or how do I do this? I don't even know where to begin. If I ever do find myself in those positions like I used to, I just go, okay, let's just fall back on recursion. Let's just start with one case. What if just this one thing happens? Because a lot of times, at least when I'm programming, I'll get overwhelmed by a problem. I'll get overwhelmed by all the different instances that I have to worry about. Like, okay, what if there's too many enemies? What if it's a different kind of enemy? What if I want this enemy spaced out a little bit more than the other enemies? Maybe this kind of enemy needs to be grouped together. You're thinking about all the if cases, all the edge cases, and what recursion forces you to do is it forces you to just think of one edge case at a time. So for me, I think it's a beautiful thing. It's made programming more automatic for me. It's made it easier to understand a lot of other concepts. It keeps my code cleaner because, like I said, all the functions are forced to be small. It's taught me about what good and bad code looks like. It makes you more comfortable when like if you're passing functions, you need to do that. Like if you're not passing functions as arguments, you're still at the beginner level. You're nothing yet. You haven't even tapped into how much potential you have. You can be so much better at this whole telling computers what to do thing and organizing all your code and having code be the way you want it to be if you start passing functions. Right? It doesn't sound like it sounds like a small thing, but like, and you might think, oh, well, I'm not doing that, but I'm still a good coder. Bro, you could be so much better. You don't even realize. And all these systems that you use, all these APIs that you use, whether it's JavaScript, whether it's, God, I can't even fucking think right now. Whether it's, web requests, whether you're using C# and you're just programming an interface, a window with some buttons and some reacts to typing. All of those will deal in callbacks, will deal in passing functions as arguments. If you're using JavaScript, then basically anytime you have asynchronous code, anytime you have two pieces of code that need to be run at the same time, but on the same thread, you're going to need callbacks. Hell, even if you're multi-threading, you're still going to need callbacks. You're still going to need to set up events where threads meet together and shit like that and exchange information. But yeah, recursion, it just pisses me off because no one practices it. They just read about it. They read articles about it. They hear about it. And so they think that that's all you need to do, that you just understand this concept and then they can understand why they would want to use it and why they would want to learn it. No, it's not like that at all. It's a technique. It's something that has to be drilled. You have to practice it. Conceptually, it's simple as fuck. Conceptually, it can't do anything for you. It's just a function that calls itself. But the reason you hear about it all the time is because those people who have decided to implement recursion as their main tool, as their go-to thing, who have taken it seriously, who have drilled it over and over again, who have entire projects written only with recursive functions, those people have gained strength, have gained knowledge, have gained skills, and they turn around and they say, whoa, hey, look at all this shit that I got from recursion. Yo, you should check this out. But what they got from recursion, you can't get from it just by reading a fucking article. You have to actually fucking use it all the time. And the other thing, there's no good resources for recursion. There's no JavaScript resources for recursion that are just fucking awesome. I think there's a SICP JavaScript tutorial, but I don't know how much. I don't know if SICP teaches you the basics of recursion. It might. It teaches you like a lot of advanced shit, but I don't know if it like drills the basics. I've never read the book, but that might be a good resource. But otherwise, there's really no fucking good recursive resources, and that goes for pretty much all the languages. And Lisp is the huge exception. But the problem is that when I try to recommend Lisp books, when I try to recommend resources in Lisp for learning recursion, most fucking people cannot get Lisp. Like, it doesn't click for them at all. There's people who have and do work in Lisp professionally, as a living, and they still don't get it. So it's not even an amount of like giving Lisp a chance or putting a certain amount of time in, or being in the right environment, like a professional environment where you have coworkers, teaching you all the ins and outs of the language. It's nothing to do with that. It's literally just up to the individual. Certain individuals seem to click with Lisp, and everybody else seems to just think it's just stupid. So while I'd be like, hey, this is how I got into recursion, pick up this Lisp book, the reality is it's most likely not going to help you unless you're the same personality type as me, where you're like questioning everything and you get really emotional and excited about things, and you get sort of starry-eyed about things, and you like to go into hyperbole about how amazing or terrible things are. If you're that kind of person, then Lisp might be right up your alley. You know, if you're the kind of person who's sort of ready to say programming is shit and all this stuff is stupid and we can do this better and I wish that things just made sense, then yeah, Lisp might be for you. But for most people, it's just not. And so that's the other difficulty of trying to get people to understand recursion is you don't even have any resources where you can be like, hey, yo, just check out this website, just read this book, just do these exercises. And you need those exercises for recursion. Recursion isn't like some other program where you really do need the practice, you need the drilling, and you need to start from something small and work your way up. You know, I don't think it's smart to start with complicated functions or complicated problems when it comes to recursion. You know, I think you should start with the simplest and build your way up because that's how I learned, and that's what worked for me. And I don't think any other way would have worked. I think I needed to be, you know, had my hand held and baby stepped through it. You know, because once you're on the other side of it, it's amazing. You can't. It's funny, and this goes for all programming. Once you're on the other side of a concept, once you've learned something to the point where you're comfortable with it, it becomes almost impossible for you to then explain it to somebody else. And I've tried so hard to not be that. But as I get older, I find myself almost just like being swallowed by the made-up language, by the made-up words. Like I can't even explain any sort of programming concept without using all of the made-up words, you know, like function and variable and object and class and scope. You know, it's like I've been using them for so long that I get them, and I've looked them up. I've looked up the definitions so many times and asked questions so many times that I have a good understanding, a good grounding of this nonsense vocabulary. But for most people, I'm not doing them any help by using these made-up words. But yeah, that's pretty much all my rambling. I just wanted to bitch about recursion. Recursion. And I'm sure this was totally not helpful, but yeah, you know, as a recap, you know, recursion has this historical significance. It will teach you different techniques. It'll make you comfortable with more advanced programming concepts. Callbacks in particular are just a key concept. It's just a basic concept that you have to learn in order to understand a bunch of other things. And it'll force you to organize your goddamn code into smaller functions. It'll get you mechanical so that you're not thinking